So, all right, can you see my slides?
Yes.
Excellent. Then that's all working fine. Cool. So, all right, can you see my slides?
Okay. Yeah. I'm done with the YouTube live. So
All
right.
Cool.
And
So how are you?
record as well. Yeah, like cloud recording can be done, so that even if there is some issue, it will continue.
Great.
So what's the current situation of UK now?
Yeah, so I've been in England since 2014, and so it's nice to be someplace and be settled. And you can actually see today it's sunny, which is quite nice. Doesn't often happen. Yeah. There aren't very many logicians where I am, but one thing that has been really nice about the pandemic is getting to, all of these talks are moving online, and getting to go to different talks, give different talks. It's really been nice to actually get to hang out with logicians again. I miss it.
Yeah, that's true. That's true. In fact, after a long time, I can meet many one virtually. So that's a really nice opportunity.
Yeah. I mean, a trip to India would also have been lovely, but probably a lot harder to schedule and organize and everything. So
yeah. So maybe I guess that we will just late by 2 or 3 minutes. That will be fine because people are joining us.
Yep.
We will just wait for some time. Oh, actually, Shantan was telling me that you gave a talk on logic supergroup as well.
Yeah, in fact, I gave this talk on it.
Yeah, I just came to know that now.
Yeah, but it's it's the thing that I've been working on, and it's also, I think, the thing that's kind of easiest to explain to a very broad logical audience, rather than doing something kind of very narrow and specific. And it's also the thing that I'm most excited about of what I've been working on lately. So.
Oh, Sara, this is Amit Kuber. He is the co-organizer.
Hello.
He's going to tell you today.
All right. Nice to meet you.
We alternate every week. Yeah.
Yeah.
And I already told you that Sara was my teacher in ILLC.
Yeah, so I got this email out of the blue, and she was like, I don't know if you remember me. It's like, yeah, I remember. So it was really lovely.
Yeah.
I was in Manchester for 4 years, like 3 years. But yeah.
In the mathematics department?
Yeah, maths department, yeah.
Yeah, so I who is it that's there? That's Jeff Paris and Alina Benkovska are there,
Jeff
right?
was there. My supervisor was Mike Prest.
Okay.
Yeah.
The logic scene in England is strange, because there's like a couple of really kind of hardcore mathematical logic groups, Manchester, UEA, couple other places, Bristol, a lot of people in Bristol. And then there's like a handful of the more kind of philosophical logicians scattered all over, and it is a little bit disjointed. And one thing that's since I've been here, I've been trying to get more of the philosophical logicians to attend the kind of general logic events and stuff. So we're kind of beginning to integrate a bit more.
In Birmingham also, there are some...
Yeah, Birmingham, that's the other one.
I guess that we can start in a minute, right, Amit?
Yeah, I'm pressing the record button and then we can
Uh-huh.
start.
All right.
So, shall we begin?
Yeah, sure.
Very warm welcome to all of you to this Logic webinar. It's our great pleasure to have Professor Sara Uckelman from Durham University. If you look at what she does, then you are definitely going to feel bad about yourself that you can't do so many things in in this lifetime. So during day she is a logician, and during night she is a speculative fiction writer. And like I don't know, like unless until I read through all these things, like I don't want to leave out anything. If I had to say everything, then I will perhaps read it out. So she has many academic interests. So in logic, her main focus is in the realm of formal modeling and interactive logic, and her work brings together tools and techniques from modern logic and artificial intelligence to help explore understanding practices of reasoning and argumentation in historical contexts. And yeah, her main research work is on developments of medieval Western Europe, particularly in medieval theories of obligations. And she's also interested in developments of logic within the epistemological and debate traditions in Buddhist India and Tibet. In philosophy of language, she does questions of meaningfulness that go beyond the standard issues of the meaning of natural languages, especially the unique issues of meaning that fiction and especially fan fiction pose. Yeah, and you can also read about which journals she's editing and what blogs she's writing. So yeah, there are many things, and there is a lot to learn from the list. And yeah, today she is going to talk about what problem did Lad Franklin think she solved. So over to Sarah.
Okay, let me get my slides up, and while I'm doing that, just say thank you very much for the invitation. It was extremely lovely to receive the email, and I look forward to having a chance to talk about some of my more recent research. In fact, this is a project that took a good 2 years out of my life, kind of working through various technical and historical aspects. And just about a week and a half ago, the paper that this is based on has gotten accepted with very minor revisions from the Notre Dame Journal of Formal Logic. So I hope that within a couple of months, the paper that this is based on will be out there and available. So this is not going to be about anything medieval, even though most of my research kind of focuses on developments in kind of Western European logic between the 11th and 14th centuries. This is actually looking at something in the 19th century, a question that came out of a workshop that I attended a couple of years ago. It was on kind of formal logic and feminist philosophy, and there was a whole bunch of women logicians there, and we were talking about women in logic. And of course, anybody who is in the field of logic knows that there are not very many women, and sometimes finding our historical antecedents can be somewhat difficult. Now, Christine Ladd Franklin is very easy to find because uh, she was one of the not one of she was the first woman to complete the requirements for a PhD in mathematics at Johns Hopkins University in the US. She didn't actually get the degree until about 40 years later because, well, she was a woman. They weren't going to give PhDs to women. But she worked with C.S. Peirce did stuff on Boolean algebras, did some more logic after her dissertation, and then moved on to like philosophy of perception and things like that. But there's a very interesting kind of story about this great problem that she solved in her dissertation, this problem that had been open for millennia. And when someone first mentioned this to me, my first thought was, I have no idea what problem this is. So that's where this paper stemmed from, to figure out what problem did she solve, but also what problem did she think she solved? Because as I will argue in this talk, modern commentators in the last 20, 30 years or so picked up a mischaracterization of what she did and have been kind of spreading a story that I don't think is true. So instead of starting with the problem, I'm going to start with the solution. So this is a quote from her PhD dissertation, which was published in '83, and it says, "The argument of inconsistency," and then you can see that formula there, "is the single form to which all of the 96 valid syllogisms, both universal and particular, may be reduced." And the proof she gives is that any given syllogism is immediately reduced to this form by taking the contradictory of the conclusion and by seeing that universal propositions are expressed with a negative copula and particular propositions with an affirmative copula. Now, if this is the solution to the problem, the first question is, what even is this? I mean, if you are not familiar with 19th century Boolean algebras, you probably don't even know how to read that formula. So that was one of the starting points of this talk. I didn't really understand what this was a solution, what the solution was, and I didn't have an idea of what problem it was trying to solve. So here is this contribution by an important woman logician in history of my field that everybody says, wow, look at what she did. And I look at it and it's like, I have no idea what this is. So it's a question about the form of a syllogism. And I'm going to give a little bit of a background to syllogistics, just refresh your memory if you haven't done it in a while, or give a brief introduction if you've never kind of seen formal versions of the syllogistic before. But this argument of inconsistency is about reducing syllogisms to a single form. And we want to ask, what is the form of a syllogism? Now, there are two possible candidates, two things that it could plausibly be, and that is the syllogism's figure or the syllogism's mood. Now, I will talk about those possibilities, but first give you a little bit of a primer on syllogisms. So a categorical proposition is a subject-predicate proposition that consists of a subject term, a predicate term, a quality, and a quantity. So Aristotle recognized four types of categorical propositions: the universal affirmative, all S are P, where S is the subject term and P is the predicate term. No S is P, the universal negative. Some S is P, the particular, or sometimes called partial affirmative. And some S is not P, the particular or partial negative. So every categorical proposition can be uniquely identified by whether it is saying something of everything or only of a subset of things, and whether it is making an affirmation or a negation. So then a syllogism is a collection of three of these categorical propositions, which have between the three of them exactly three terms, each of which occurs exactly twice. So two of the propositions are the premises and the other is the conclusion. The predicate of the conclusion is called the major term, and the premise that has that term in it, by convention, is written first. It's the major premise. The subject term of the conclusion is the minor term, and then there's one more term that only occurs in the premises, and that's called the middle term. It's the one that links the premises together. So just to say that while kind of the roots of this is in Aristotle, the presentation that I'm giving is going to be Aristotelian. So drawing on his foundations, but somewhat more, I'm not giving you an account of Aristotle's theory, I'm giving you an account of the Aristotelian syllogistic. So you can arrange these different terms that you have in a syllogism in different ways. So the predicate of the conclusion is always represented first, and the subject second. This is just an artifact of how these propositions are expressed in ancient Greek. And then you can either have the predicate of the conclusion be the predicate of the major term, major premise, and the subject of the conclusion, the subject of the minor premise. Or the middle term can be the predicate in both premises, or it can be the subject in both premises, or it can be kind of reversed from the first one. So each of these different ways of arranging the terms involved in a syllogism give you a figure. So the first figure, second figure, third figure, and fourth figure. If you then, so you can see what I've got here is just where the terms are, and then there's these lines underneath. If you fill in those terms and make them into categorical propositions, so all M are P, some S is M, all S are P, something like that, then what you get is a mood. So here are the syllogisms that are traditionally taken to be valid, divided by each of their figures. And then you can also see that they have names on the right-hand side. These are mnemonic names that were developed in the Middle Ages. The details of the names don't matter here. They just give us a convenient way to be able to refer to different syllogisms without having to write them out. So if we are interested in reducing syllogisms to a single form, then kind of two natural questions are, what is the form of a syllogism? Well, is it the figure? Is it the mood? It's not the figure. So we had four figures, but yeah, so it can't be the figure because back in Aristotle, we already have a method of reducing all syllogisms that are in the second, third, or fourth figure to syllogisms in the first figure. So that, if the reduction of syllogisms to one form is supposed to be solving a problem, then form can't be figure because this had been solved back in Aristotle. So there's no problem here. The question of, is it mood, is also not going to be, it's not going to be the mood, simply because the question of whether you could reduce all of the syllogisms to a single mood, so one of these, wasn't a question that people were interested in. Now, Aristotle showed that you could reduce everything to the first figure, and within the first figure, you could reduce it to either Barbara, the first one listed there, or Chaleret. So we can reduce them to these two, and that was good enough for 2,500 years. If you look at kind of like later logical commentaries on Aristotle in late antiquity or in the Middle Ages, nobody was interested in the question of, can we reduce this even further? So while if mood were the answer to the question of what is the form of a syllogism, then maybe Ladd did show something that solves this problem, but it wasn't really an open problem that people were interested in. So one other possible kind of brief digression I want to make is about logical hylomorphism. So hylomorphism is this notion that things are made up out of form and matter. So in Aristotle, hylomorphism comes up as a metaphysical thing. So the nature of objects is that they are this combination of form and matter. Alexander of Aphrodisias, one of the later late antique commentators on Aristotle, developed this notion into a logical one, so that syllogisms also have form and matter in the same way that like objects do. So you might want to say, okay, is this the notion of form that is at play when we are asking, can we reduce all syllogisms to one form? The answer is no. This is because when Alexander says form, he just means figure. By the 14th century, the opinion of like what the form of a syllogism was had shifted, but form was just mood. So there isn't some form, some other type of form, something other than figure or mood that is being talked about when we talk about the form of a syllogism. So it's not figure, it's not mood, and if it is something else, it's not clear what this something else could be. Nevertheless, there are some really interesting comments. So these are some papers by Susan Rusinoff and Ati Pietaarinen written in the last 20 years or so about Ladd's contribution. So Rusanoff says in 1883, while a student of C.S. Peirce at Johns Hopkins University, Christine Ladd Franklin published a paper titled On the Algebra of Logic, in which she develops an elegant and powerful test for the validity of syllogisms that constitutes the most significant advance in syllogistic logic in 2,000 years. Rusanoff then says, in this paper, I bring to light the important work of Ladd Franklin so that she is justly credited with having solved a problem over 2 millennia old. Pietarainen, in the preprint version of his paper, says that Ladd's result was a groundbreaking discovery involving the reduction of Aristotelian syllogistics into a single formula. Interestingly, in the published version of this paper, the phrase groundbreaking has been removed. I'm not entirely sure what, kind of what went into removing that that phrase, but it does seem to indicate that maybe there was beginning to be a recognition that sort of the account that Rusanoff gives of this solution to a 2 millennia old problem isn't necessarily the right way to think about what happened. However, Pietarainen does say, again, quoting Rusanoff, that Ladd Franklin, in fact, managed to solve, or at least to see the solution to, the problem that was over 2 millennia old. So he still does think that there is this long-standing open problem in the syllogistics that Ladd was the first person to solve. Now, before I return to kind of what this problem is, other than just say that everyone talking about it seems to assume that we know what it is, I want to say something more about Ladd's contribution to the development of algebra and how to actually understand her solution. So maybe if we can figure out what the solution is for, we can figure out what problem it was solving. So in her dissertation, Ladd identifies 5 algebras of logic due to Boole, the original one in the Laws of Thought, but then also Jevons, Schroeder, McCall, and Peirce. Her aim was to introduce a 6th algebra that addresses what she sees as drawbacks in the previous attempts. So Boolean algebra was a huge focus of the development of formal logic in the 19th century. This is all happening kind of pre-Frege, so we don't have kind of widespread predicate logic going on. And there are different ways that you can construct logical algebras. The basic components of Ladd's algebras are subject and predicate terms. So they can either be atomic ones, which are indicated with just A, B, and C, lowercase letters, but you can also combine terms into more complex ones. So you can negate them. So A with a bar is what is not A, and you can take union and intersection. So this is indicated with plus or times, but sometimes we'll just omit the times symbol, and A times B will just be listed as AB. We have a term that indicates the domain of discourse. It's the infinity term, and the complement of that is, of course, the empty discourse, or 0. Now, Ladd says that there are 3 things that we can do with these terms. The identity between a subject and predicate term can be affirmed, the identity can be denied, and complex terms can be negated. So what you can see on this slide, we show how to form negations from atomic terms just by putting the bar over the top. When it comes to identifying the ways in which complex terms can be negated, Ladd says that there's kind of 3 different ways you can do it. Boole and Jevons do it one way, De Morgan does it another, and Schroeder another. The details don't matter. Just know that you can negate complex terms, but it's not in a, it isn't immediately obvious that there's one particularly right way to do it. Now, here we're talking about affirming or denying the identity of subject and predicate terms, so statements of identity. But you can actually also express the Aristotelian categorical propositions if we can find a way of assigning quantities. So if we want to be able to say not just that A and B are identical, but that maybe A is a subset of B, or that the intersection of A and B is non-empty. So that's saying that all A's are B, or that some A is B. Ladd says that there's two ways that we could kind of turn things into categorical propositions. We can either assign the quantity to the copula, to the thing that kind of joins the two terms together, or we could assign it to the subject. If you assign the quantity to the copula, then you need to have two copulae, one that is universal and one that is partial. And this is the way that McCall and Peirce take in developing their algebras. But if you assign the quantity to the subject term, then only one copula is needed. And this is the route that Boole, Schroeder, and Jevons take. So here I've got just a table that summarizes the different types of categorical propositions and the ways that they can be represented in these various algebras. So we've got kind of the traditional statements, all A is B, no A is B, etc. And then Boole and Schroeder's formalization, Jevons, McCall's, and Peirce's. So in the Boole and Schroeder approach, you'll see that all A is B is represented as A is identical to VB. V here is not a categorical term like A or B, but it's a special designated term that just picks out an arbitrary indefinite class. So A is the intersection of this indefinite class and B. In Jevons' account, so looking at the partial propositions in Jevons' representation, C works in a similar way, but it's not a distinguished term. So in Boole and Schroeder, V is a particular term that picks out an indefinite class. In Jevons, C is just some other term. And so here you can see that Boole and Jevons only have one copula, namely the identity sign, but that McCall and Peirce have two. So McCall has these double dots, and then the double dots with the line in between. Peirce has the sideways Y, and then the barred version of that. So which of these two ways is preferable? The advantage of the Boole, Schroeder, Jevons approach is that only one copula is necessary, so you have simpler structures that you're working with, fewer rules that you need to explain how this copula works. The advantage of the McCall or Peirce option is that copulas that include their quantity can either link terms so that you can say something like, all A's are B's, or propositions so that you can make statements of implication. So for instance, A sideways Y with the bar over it can be read either A is not wholly contained under B, or A does not imply B. So these terms can be used kind of indifferently to pick out classes of objects or propositions. The other advantage is that there's a correspondence between the quantity of the copula and its quality. So if you look over here, the universal ones under McCall and Peirce are all affirmative, and the partial ones are all negative. So there's this nice sort of duality that you get when you apply the quantity to the copula. Now, this is one of the points at which reading Ladd's dissertation it's difficult, even if you're familiar with Boolean algebras as a modern logician, because this kind of slipperiness between whether terms stand for classes of objects or whether they stand for propositions. This sort of ambiguity is something that we try to avoid in contemporary logic. And so having to kind of always keep track of these different ways of reading the propositions can be quite time consuming. So Ladd wants to, so she thinks that kind of the McCall and Peirce route, that these advantages outweigh the advantage of just having one copula. But she differs from them in which one she takes as basic. So instead of saying that A is wholly B or A is not wholly B, so the complement of that, instead of taking those as basic, she's going to take statements of inclusion and exclusion. So A is not, A is wholly not B. So A and B are completely excluded from each other. Or A is partly B, there is an overlap between the two of them. So she's going to take essentially the E and the I claims as basic instead of the A and the O. This has an advantage in that the part inclusion and the complete exclusion combinators are symmetric. So A is completely excluded from B, may be read either forward or backwards. So if A is completely excluded from B, B is completely excluded from A, and same with the partial inclusion. Whereas saying that A is a subset of B or A is not a subset of B, these are not symmetric. So another advantage is you can always interchange between the inclusions, so the A and the O claims, and the exclusions, the E and the I's. So you can do this just by changing the sign of the predicate and changing the copula from the inclusion to the exclusions. Going the other direction, every exclusion is equivalent to a pair of inclusions. So if you have, say, A is completely excluded from B, then all A's are non-B's and all B's are non-A's. So the advantage of this approach, which takes the advantage of Schroeder and Peirce's approaches over Boole's and McCall's and Jevons, and adds this further advantage that you have this symmetric copula, you have that categorical statements, all A's are B's, and hypotheticals, A implies B, are treated identically in the formal system. Furthermore, we can kind of represent arbitrary premises and conclusions. So if we let P denote a premise and see some conclusion that follows from P, then we can represent this either by saying that P and the complement of C, so the premise and the negation of the conclusion, that combination is excluded, or we can say that the negation of the conclusion is excluded from the premise. So there's a number of different ways that we can express other sorts of claims using these propositions, using this symmetric combinator. So with the kind of universal domain term, the infinity term, we can express existence and non-existence claims. So if you say that X is excluded from the domain, then that is saying that X does not under any circumstances exist. And if you say that there is an overlap between some term X and the domain, that's just the same as saying there is at least one X. So you can even say very simple non-categorical quantificational claims. And you can translate between propositions and terms. So the algebra that Ladd develops, because it is talking about both propositions and terms, doesn't have the zero term that we said is kind of the complement of the infinity term. This means that we can kind of drop reference to the infinity term because if it's not referred to explicitly, we could always kind of, everything is being stated against the background of the entire domain. So for these statements of existence and non-existence that I have labeled on this slide, we could just rewrite them without the infinity term. So to say x v bar just says x does not exist, and x v just says x does exist. Then we can translate from categorical propositions such as no A is B, so A v bar B, into statements about terms. The combination AB does not exist. So there is this really robust kind of interchange between terms and propositions. That sets the stage for kind of the language that she's using and her motivation for picking the copula that she has. Then she goes on to say that there are three things that you want to do with a symbolic logic. And this is interesting because, again, we're working in the context of 19th century developments of Boolean algebras, a very different view about what the nature of logic is than what we might have nowadays. So these are the three things that you do in logic if you are a 19th century, algebraic logician. There's the uniting and separating of propositions, the insertion or omission of terms, or as she calls it, immediate inference. And then there is elimination with the least possible loss of content, or syllogism. So if you recall back to our definitions of a syllogism, there's the three propositions with three terms, and then you can think of there being between the premises, which involve all three terms, and the conclusion, which just involves two, an elimination of a term has happened. And that's what a syllogism is. So this is what we're going to focus on now, because this is where her reduction theorem comes up and is interesting. So she says that the most common object in reasoning is to eliminate a single term at a time, namely one which occurs in both premises. So this goal of logic, she says, can be accomplished via a particular inference form. If A is B and C is D, then AC is BD. So that's what we have represented in Formula 1. So if the exclusion of A and B, the exclusion of C and D is excluded from the combination of A and C or either B or D. So we'll simplify this this construction a bit so that we can see more clearly what's being said. If we take D to just be the complement of B, so then adding D to B gets us our domain of discourse. So then we can always rewrite, if we do that resetting, we can rewrite the first formula as the second one, which says that you can, if A is excluded from B, and the complement of B is excluded from C, and C and A are not excluded from each other, those three propositions are inconsistent. So that is how you can understand what Formula 2 there is saying. But that just is.
Sorry.
Yeah?
There is a question in the chat.
Oh, I'm sorry. I can't even see anything in the chat. I'm happy to take questions throughout. So could you read it for me?
Yes, I can read it for you. Yeah. So this is from Agnivo. So maybe a silly question, but here to talk about non-B. Non-Bs, will approximation identity be helpful anyhow? Where equality is just a binary map, so non-B means all A such that equality of A with B is less. Equalness of A with B is less than 1.
Ooh, yeah, so I mean, this sounds like a question about how we would kind of translate this into into the Boolean algebra, where you've got these 0 and 1 as your top and your bottom. I'm not sure I would be able to answer that question without kind of sitting down with a piece of paper and kind of working it out. I think it's probably at this point better to just kind of think not in terms of 0 and 1 or truth values like that, but just in terms of combinations of things. So B either picks out a class of objects, in which case non-B picks out its complement, or B picks out some true proposition, in which case non-B just picks out its negation. So that might be an easier way to think about it kind of at this point. Great. If any other questions come up and I don't notice, please interrupt me again.
Sure. Thanks.
Yeah. So this form that we have here, this kind of general representation of inference involving the elimination of a term is, as Ladd proves on page 40 of her dissertation, the single form to which all of the 96 valid syllogisms, both universal and particular, may be reduced. And the way that you do this is you take your two premises, you represent them in the with the symmetric copulae. You take the negation of the conclusion, so the contradictory of it. Make sure all of your universal propositions use the negative copulae, and all of the particular ones, or all the partial ones, use an affirmative. And then you will always be able to represent a syllogism as a statement of the exclusion or inconsistency of the two premises and the negation of the conclusion. So she then says that from this theorem, a corollary follows in a form of an easy-to-apply rule stated in ordinary English for identifying whether any syllogism is valid. You take the contradictory of the conclusion, see that the universal propositions are expressed with the negative copula and the particular ones with the affirmative. If the two propositions are universal and the other particular, and if that term only, which is common to the two universal propositions, has unlike signs, so the term that's being eliminated, does it occur positively in one universal proposition and negatively in the other, then and only then you have a valid syllogism. So here's an example. This is the syllogism Barocco. All P is M, some S is not M, therefore some S is not P. This is equivalent to the inconsistency of the three claims that P is excluded from not M, S is not excluded from not M, and S and P are excluded from each other. So those three statements together are themselves inconsistent. Now, an interesting thing is that Aristotle already knew how to do this sort of reduction. So he was able to reduce both Barocco and Boccardo, which is basically the same syllogism with the terms term order swapped and premise order swapped. He was able to reduce both of these to the first figure syllogism Barbara via a reductio ad absurdum. So you take the contradictory of the conclusion, combine it with the universal proposition, and then you conclude the contradictory of the other proposition. So this is, it's the same sort of representation, same sort of reduction that's going on. And so Aristotle already knew how to do this. He did it. There is a little bit of a difference between what Aristotle did and what Ladd is doing. So instead of taking Barbara as basic and then reducing Barocco and Boccardo to Barbara, what she said is that you can just take as basic the inconsistency of the three claims, all M are P, all S are M, and the negation of the conclusion, not all S are P. So because these three are inconsistent, you can take any two of them and the denial of the third, and this will generate Barbara, Barocco, and Boccardo. So in a sense, instead of reducing Barocco and Boccardo to Barbara, she's reduced all three to this statement of inconsistency. This is the sense in which the three syllogisms are reduced to one form. So it's not that we're taking two syllogisms and reducing them to another syllogism, but we're taking all three syllogisms and reducing them to essentially something different, a statement of the inconsistency of the premises and the negation of the conclusion. So why do this? Ladd says that if for the usual three statements consisting of two premises and a conclusion, one substitutes the equivalent three statements that are together incompatible, one has a formula which has this great advantage. The order of the statements is immaterial. The relation is perfectly symmetrical. So whatever order you put the three premises, they're still going to be inconsistent. So in addition to this being symmetric, she says the result is a source of great simplicity. there's only one valid form of the antilogism, so that's what she calls this, instead of the 15 valid forms of syllogism, which common logic requires us to bear in mind. So kind of the question of which syllogisms you take as valid kind of has changed over the years. It depends on whether you accept existential import. So the fact that she says 15 here and we had like 26 on our list, you don't need to worry about that. More benefits of approaching syllogisms in this way. If all three of the claims are either written as E claims or I claims, then you have kind of another increase in both simplicity and symmetry, because all of these are kind of maximally simple and can be simply converted. So if no SRP, no PRS, you can always do reverse of the terms like this. And then if we admit infinite terms, so complements of things, you can always rewrite any proposition into a symmetric one. So all S are non-P, which is an inclusion statement, is equivalent to no S is P, which is a symmetric statement. So now we have a sense of what she was doing and why she was doing it. So reasons of symmetry and simplicity motivating this identification of a form that does this elimination of terms for the syllogism. So now I want to say, and I'm conscious of time, I hopefully don't have too much more I want to say, a little bit about what she thought she was doing. So according to her, her algebra contains a solution of what Mr. Jevons calls the inverse logical problem. And this problem is, given certain combinations inconsistent with conditions, determine what those conditions are. So there's a more precise characterization of the inverse logical problem that I've quoted here, but I won't read it out. You can look at it if you want. Basically, the idea is it's a combinatorial question, and Jevons was unable to come up with any systematic way of identifying what combinations are going to be inconsistent other than going through them all exhaustively. So his solution, he says, consists in inventing laws and trying whether their results agree with those before us. So this is very ad hoc. Now, Schroeder and Boole also tried to solve this problem without really any luck. So he wanted to, Boole did accomplish a solution to this problem, but with all of the kind of concomitant problems that so all of the disadvantages of his algebra are kind of inherited by his solution to the problem. So Boole's rule get the conclusion right, but Ladd is still quite critical of it. She says it's a terribly long process. It's more theoretical than practical. And the way that you have to kind of alter the representation of the conclusions is not that which is most natural or most frequently useful. And this is because Boole is interested in logics of extension rather than intension. And so she has all of these reasons for thinking that her solution to Jevons' problem is superior to Boole's. So Ladd thought she was solving a problem due to Jevons, something in the kind of contemporary issues in algebraic logic. So why does Rusanoff think that what she solved was Aristotle's problem? So Rusanoff says in one paper that the problem that Aristotle posed and attempted to solve is to give a general characterization of the valid syllogism, though he did not succeed in providing a unified and complete treatment of the syllogistic argument. These are strange things to say, given that if you read the prior analytics, Aristotle did give a complete characterization in terms of being able to reduce all the valid syllogisms to ones in the first figure, and giving metaproofs showing that you would never be able to reduce any of the non-valid syllogisms. So we're still left with this question of why people have said that Ladd solved this problem of Aristotle. And first, one of the things that you need to think about at this point is, well, what counts as a problem? How do you get to solve a problem? You can't have a solution if you don't have a problem. And so you might want to say, well, does a problem have to be recognized as a problem in order for it to be a problem? So the problem that Ladd solved, and there is no doubt about the fact that her argument from inconsistency was a genuinely new development in Boolean algebras that solved the problem she was trying to solve. The question is, did it solve some 2 millennia old problem that nobody was ever interested in or ever articulated or ever stated as a problem before the 19th century? Or was it really only a problem once somebody formulated it as a problem? So that's one kind of thing that you have to think about and trying to answer the question of what problem did she solve? So the last thing I want to do is say a bit about how I think Ladd's solution to a problem of Jevons became interpreted as a solution to a problem of Aristotle. So the first review of her paper, of her dissertation, published in the same year, doesn't even mention this result as anything particularly, just surveys her new notation and explains how she can rewrite algebraically old forms of the statement in a way with great brevity and facility. The first kind of singling out of this argument from inconsistency or the antilogism as an important fundamental contribution comes from about 25 years later, 1909. So Brown mentions when Mrs. Ladd Franklin demonstrated the one simple form underlies all syllogism. Then in the 20s, you get quotes of a statement by the late Professor Josiah Royce of Harvard. So this is a paper by Shen in 27, who says that, quoting Royce, there is no reason why this, Ladd's contribution, should not be accepted as the definitive solution of the problem of the reduction of syllogisms. It is rather remarkable that the crowning activity in a field worked over since the days of Aristotle should be the achievement of an American woman. And so this is also quoted in Spillman in 2012. Now, this source for this is actually some newspaper articles in the 1920s. This is around about the time that Ladd was finally recognized with the degree of a PhD in recognition of the work that she had done roughly 40 years earlier in this dissertation. So Royce here is kind of like the writing to popular media, trying to explain what the importance of her contribution is. And he describes it as this crowning achievement in a field worked over since the days of Aristotle. So here's just another quote from this. So the Hartford Courant in 1926 also kind of has some references of things that Royce said. The Aristotelian system was never fully demonstrated until Mrs. Ladd Franklin worked out the whole method at Johns Hopkins. So at some point, there was a shift from kind of these popularizing words of Royce saying, this is an achievement in the development of Aristotelian syllogistic, to this understanding of her solving a problem that was due to Aristotle or that Aristotle had, rather than just saying, okay, there's this kind of continuous development. This problem was articulated in the 19th century. It's in the context of Aristotelian syllogisms, but it wasn't a problem of Aristotle's. It was a problem that comes from representing Aristotelian syllogistics in an algebraic setting. That's the problem that Ladd solved. That's the problem that she thought that she solved, and it wasn't a 2.5 millennia open problem due to Aristotle. That would have been cool, but there just was no problem that was exercising logicians for 2.5 millennia, unlike what people like Rusanoff and others have said. So I've got the bibliography in case I can come to this if you want to see any of the particular references, but otherwise I will end here and say thank you.
Thanks a lot. We have never really thought about what we think of logic has undergone so many changes.
And just from the 19th century too.
Yeah, that was a completely different viewpoint. So if any participants have any questions, you're all welcome to interact with her. Yeah, I wanted to ask, like, this is such a descriptive way of talking about things. So
Yes.
how did you get interested into this?
So it was really, I got interested from this workshop that I went to when one of the other participants said something about, Christine Ladd Franklin, she solved this open problem that had been in the syllogism that had been existing for since Aristotle, and kind of a combination of things. I am known for doing work in the history of logic, and so I felt a little bit bad that apparently there was this big open problem and I didn't even know what it was. So I was a bit embarrassed and wanted to go and find out. I'm also fairly vocal and an advocate for kind of looking at the role and position of women in logic, both in contemporary settings, but also I think it's important to kind of look at our history and make sure we're not overlooking these people. And Ladd was somebody that I had heard of, but didn't really know anything about. And so I kind of decided, okay, I need to change this. I need to figure out, what exactly was she doing? And is she solving this millennia old open problem? And I should have known about it by doing research in kind of medieval development. Or is there more to the story than that? And so if anybody's interested, her PhD dissertation, you can get it on Google Books. It's so there we are. So Peirce edited this Studies in Logic that was published in '83. It's a collection of papers of which one of them is her PhD dissertation. So if you just want to search Google Books, you can find it yourself. It's about 50 pages long, and when I first sat down to read it, I could read it at about 2 pages a day, because as you say, the approach to logic in the 19th century is just so completely different from what we're doing nowadays.
I had two queries actually. So one of them is that you mentioned the name of Shane. Is it the same Shane who is working on diagrammatic logic? And
no, that is Shane.
That is different one.
Shane.
Okay, yeah. I honestly don't know who this person is, other than that, he has this paper on the Ladd Franklin formula from 1927. So, yeah.
Okay, so it's not. And another thing is that, like, we all know about, like, as a logician, we know Boolean algebra and all. And from this work, I could realize that large algebra is not that bad. It is indeed good one. But why it is not that popular yet? Do you have any opinion regarding this? So that's the question.
Yeah, I don't know. So again, prior to looking at these things, I had even read some of the laws of thought. I know some stuff about kind of Boolean algebras as they're used in contemporary logic. But going back to the 19th century, I hadn't realized that there were so many different competing accounts of algebra, and how, I believe that they are all kind of intersubstitutable, interchangeable with each other. And so, hence kind of the focus of Ladd trying to argue that even if you can do all of the same things in all of these algebras, nevertheless, you might want to prefer some of them over other ones because of symmetry or simplicity. And so I find it really interesting that Boole's algebra was not the one that she she kind of discounted that fairly quickly on as, not having the preferential characteristics. And yet at some point, when we think of algebras, we think of Boolean algebras. We don't do Schroderian algebras or Jevonsonian algebras. So I don't really know why his became the one that we talk about. It's another interesting historical question. Yeah.
I guess, sir, you do have some questions, or hello? So anyways, it's a really nice presentation. I just liked it. So
Oh, thank you.
Yeah.
It's always fun to kind of be a female logician getting to talk about other female logicians. That's also a nice thing to be able to do.
It's fascinating, seriously.
Any other comments or questions?
No, can I, Amit,
sure.
this,
Yeah.
Mihir Chakraborty speaking, yeah. No, my question was, I don't know whether it was already explained in the talk, the single expression that actually can accommodate all the syllogisms. In this single expression, when we read and when it was read, then contradiction or is contradictory or is absurd or something like this was uttered. Is it so? I mean, the main the single expression that is I mean which was shown in the starting slide.
Mm-hmm.
Can you just
right.
show this one? Yeah.
Yeah.
And how do you read this expression apart from say just symbols?
Yeah. So what this is saying is that the three statements, A is completely excluded from B.
Are they statements?
The complement, yeah. So each thing in brackets represents a proposition. So the first one is A is completely excluded from B.
Right.
The complement of B is completely excluded from C.
Right.
C and A are not completely excluded from each other.
Right.
These three statements are completely excluded from each other, is the way to read this.
Completely excluded from each other.
Yeah.
Okay, we have some kind of intuitive understanding of that. That's no doubt. But when you say completely excluded from each other, what is referred to in this sense? I mean, they cannot hold together. Is it like something like that?
Yeah. So either that the properties are inconsistent, or that the intersection of the sets is empty, or that they're contradictory.
No, here is the point. Either you have to utter inconsistency or contradictory or something like this, right?
Yep.
So my question would be, what does that mean? I mean, this word mean?
So one thing that makes reading Ladd's work difficult is that there isn't any semantics behind any of this. It is purely this kind of calculus that with rules for manipulating formulas. You can give a set theoretic semantics for this, where A and B are either where A and B are interpreted for kind of subsets of a domain, and then the exclusion symbol here is doing kind of double duty, both as kind of empty intersection or non-empty intersection, and also statement of kind of conjunction or disjunction, so all being true or all being false. This is one of the things, again, that makes reading her work hard, is because these letters can either stand for terms or for propositions, and the activity, the combinators can therefore either be doing set theoretic work or truth functional work. And this kind of the distinction between these two different levels is not made explicitly in her work.
Yeah, actually, here is really I always have had some difficulty here, because when you, as you said, either you use your set theoretic interpretation in mind, you have set theoretic interpretation in mind, or you have some notion of truth in your mind.
Yep.
But the algebra, in the algebraic expression, really neither of them are present. I mean, should not be present also in any case. So there should be some other way of understanding inconsistency or contradictoriness purely from syntactic angle or algebraic angle. Without that, I think this is a kind of, it is okay, fine, but this may not be, I mean, that satisfactory. This is my comment.
Well, I think that this is just kind of reflecting a difference in the requirements of what we put on logic nowadays. From the point of view of kind of developing a Boolean algebra in the an algebra of logic, I should say, not necessarily a Boolean one, in the 19th century, this is all that you need. You don't have to have anything beyond just statements about what the combinators are, what the basic terms are, how to combine them, how to eliminate them, and what the rules are. So it really took kind of developments towards the end of the 20th century, or sorry, end of the 19th and into the 20th century, for us to start kind of separating out these kind of the syntactic algebraic side and the semantic algebraic side. It wasn't the sort of distinction that they were making in the 19th century.
Okay, thank you very much.
Yeah, thank you.
Nice talk in any case. Yeah, we learned a lot.
Thank you.
Yeah.
Yeah, if there are no